Hello, since, as always, the questions are graded for completion, I want to go through the right answers with you so you can use it to study for your test. This is for assignment number 3. All right, exercise 3.1. For each of the following sets of premises, think of a conclusion that follows deductively, then write the argument with that conclusion in standard form. So number 2 reads, each cake requires 5 eggs. We need to make 4 cakes. Well, those are each premise. Number 1, each cake requires 5 eggs. Number 2, premise 2, we need to make 4 cakes. So what's the conclusion? So conclusion, we need to buy 20 eggs. Same here. It's pretty straightforward. Premise 1, the probability of rolling an ace with a fair die is 1/6. The probability of rolling 2 aces with a fair die is the probability of rolling an ace on the first die times the probability of rolling an ace on the second. And so the conclusion from that is, so the probability of rolling 2 aces is 1/36. If you have trouble with the math here, don't let that intimidate you. Remember, the answers are in the back of the book. Next set. If we define a deductive argument as one that is in which it is impossible for the conclusion to be false if all the premises are true. In other words, if all the premises are true, the conclusion must be true. It must follow. Then which of the sentences are true? This is called, some texts and logicians would refer to this as valid deductive argument. They're valid because if the premises were true, the conclusion would have to be true. All right, so can a deductive argument have a false conclusion? Sure, that's true because it could have a false premise. It's just if the premises are true, the conclusion would have to be true. It doesn't mean it always has a true conclusion, because sometimes it might have false premises. Number 4, a deductive argument can have all false premises and a true conclusion. Let's see. Yes, when the premises are false, it's like anything can happen. There's no rules. It's just if the premises are true, the conclusion has to be true. That's the rule. And so if there's false premises, you might have a true conclusion. So that's also true. A deductive argument can have one true premise. Again, we're still not talking about all true premises. So, so you can see where this is going. So it could have one true premise, but also several false premises and a true conclusion. Sure, that can happen. The only rule is that if the premises are true, the conclusion has to be true, if all the premises are true. Number 8, a deductive argument can have the same sentence as one of its premises and its conclusion. Oh, yes. It's just not a very interesting argument, but I suppose you could just say, like, I have brown hair, so I have brown hair. That would be a valid deductive argument. It would just be one that's not worth making, so that's also true. All right, next one. For each of the following arguments, indicate in a general way the definitional or structural features that make it deductive. Oh, sorry, so say whether it's definitional features or structural features that make it deductive. If an argument requires the addition of an obviously true but unstated premise, say what the premise is. All right, so number 2, Mary is Michael's mother, therefore Michael is Mary's son. You can see this is a valid deductive argument because it follows sort of from what the definition of a mother and a son are. And maybe we would need to add a premise. Mary is Michael's mother. Michael is a boy. Maybe you'd also want to put the definition of son. A boy who, how should I say that? A boy who has a mother, is that mother's son? Maybe that's a little, I should write it out. Sorry about that. But therefore, Michael is Mary's son. You can just see from it's about the definition of mother and son that makes this a valid deductive argument, so it's definitional. Number 4, every senior owns a smartphone. Carlos does not own a smartphone, therefore Carlos is not a senior. The way I see that this is structural is I kind of try to put it in symbolic form, something we call symbolic form. So I say every A owns a B. Carlos does not own a B. Therefore, Carlos is not an A. Right? So like all A's are B's. Carlos is not a B, therefore Carlos is not an A. You can kind of see that there's a structure that sort of, if the premises are true, the conclusion would have to be true. And so it's a structure of the argument in this case. And same for number 8, you can see. A person should not be judged guilty of murder if he was certified as insane at the time of the act of killing another person. So I'm going to put this in the format, if A, then B. If he was certified as insane, he should not be judged guilty of murder. The court has accepted the certification of insanity of Smith. So basically, if A, then B. A, therefore, Smith should not be judged guilty of murder. So it's basically like this. 1, if A, then B. A, so B. So you can see there's something structural here that makes it a valid deductive argument. So it's structural. All right. None of the following arguments is deductive, or in other words, a valid deductive argument. Describe a situation in which the conclusion of each of the following arguments could turn out to be false, even though the premises are all true. All right, so number 2. Every senior can register for this class. Sally is not a senior, so Sally cannot register for this class. Well, look, I mean, if we really think about this first premise, every senior can register for this class, it doesn't say anything about like non-seniors can't register. It's just every senior can, but maybe some juniors have enough credit that they can also register for the class. And Sally is not a senior, but maybe she's one of these juniors that has enough credits, so she can also register for this class. So we see that this is an invalid argument because there could be a situation where even though Sally's not a senior, she could still register for the class, because it just says every senior can register for this class. It doesn't, maybe if it said every senior and only seniors can register for this class, then it might be different, but it doesn't say that. It just says every senior can register for this class. And number 6, this one's a bit silly, sorry. Perhaps the lesson on this one will be different. But let's look at it. In Shakespeare's Hamlet, Polonius gives the following advice to his son Laertes. This above all, to thine own self be true. Right? Like, be true to yourself. And it must follow as the day follows the night, or as the night follows the day. Thou canst not then be false to any man. I mean, it just seems like even if you're true to yourself, you could still lie to somebody else. I didn't quite see how this was even that tricky, but I guess they're saying, but here's the takeaway from this is even if you think the question is a bit weird and you can't answer it, go back in the back of the book, the answers are there. So I just copied and pasted this question to try to show you that even if there's questions where I'm like, oh, this is a bit tricky or it seems almost too easy. So here's the answer found in the back of your book. The point is just put something down, right? It's a completion grade, and I'm going to go through the answers. So this requires some interpretation as to what it means to be true to oneself or others. Consider this plausible case, however. You say something you believe to be true, so you're being true to yourself, but it's not. So you're being true to yourself, but the person to whom you are speaking is thus deceived about how things stand, so you're false to another person. So they're interpreting be true to yourself basically as you would always say something true in front of yourself, but maybe you could say something you thought to be true. Anyway, so the point is it seems like there's an exception to this rule. All right, I hope this helped answer any questions you have about this assignment.